All right, I'm giving you another example here, and this one looks like a monster. But before you get started on any math problem, what I need you to do is look at it. And you're sitting there saying, of course, Miss Homer, I look at it, but do you actually look at it and take it in, or do you just start the math? I will admit, personally, oh, I got a problem. Let me just grab this pencil and work it out. It's good, but sometimes you can save time by giving yourself the time to think. So if I look at this problem right here, I see 24x squared plus 108x plus 120 equals 0. Good news is, if I move my little face here for a second, the good news is that's the standard form, right? So we're in standard form here. The bad news is I'm going to have to find b squared, which is 108 squared. Now, calculators are here, but even so, if I put in 108 and I square it, that's still, I'm going to have to deal with the number 11,664. I'm failing it. So what I would suggest, and the better that you are with your multiplication tables, the easier this will be. So practice them. But as I look at this, I see 24, I see 108, and I see 120. All right, so my thought process is, I'd really like to get rid of that coefficient of x, right? I'd really like to get rid of it. So what I'm going to do is I'm going to see, I know that 24 gets divided by 24. I could factor out a 24, but can I do that on all of them? Well, is 108 divisible by 24? Not exactly. Although I just had another thought as I was doing it, and this is the great thing about math. This is what's fun and exciting about math, is that at first I was like, oh, I'll factor out a 12 because each of these are multiples of 12. But since I'm doing the quadratic formula anyway, why not divide everything by the same thing? Okay, so I changed my mind and I'm going to do it this way. That's fine. That's what math is. If I divide every single thing by 24, every single thing, what am I going to get? I'm going to get x squared plus, here is 4.5x. And you're like, oh, I have to find the vector. Nope, we're using the quadratic formula. And then 120, oops, I'm over here. 120 divided by 24 is 5. So it doesn't look, this looks much less intimidating if you don't hate decimals. I'm going to use it this way, okay? I could have divided by 12, and this would have been, sorry, people race down my street all the time, 2x squared plus 9x plus 10, and then plug it in the formula. But it's going to work the same way as if I use the decimal, right? So 4.5 is my b. So everywhere I see a b, 4.5, right? A, in this case, because I like to make it that way, is 1. And C is 5. Let's plug them in and go. See what happens, right? All right, so negative 4.5 is just going to hang out, plus or minus the root of 4.5 squared. Maybe it's not wonderful, maybe it's not easy, but you have a calculator. 4.5 squared is 20.25, right? And then, sorry, go back, minus 4 times 1, which is negative 4, times 5, which is negative 20, all over 2 times a, which is 2. 2 times 1 is 2. So we have negative 4.5 plus or minus the root of 20.25 minus 20 is 0.25, all over 2. Okay, and then I can do this one. 0.25, that looks a lot like a perfect square that I know, right? So if I want to, just test it out. That's the thing with calculators. Just test things out. Have fun with it. 0.25, when you take the square root, is 0.5. This is great. This is great. This is showing something. I like this. I'm glad I decided to do it this way. So what this really says is negative 4.5 plus or minus the square root of 0.25 is 0.5 divided by 2. So let's set up those two problems so that we can see it. We have negative 4.5 plus 0.5 divided by 2, and negative 4.5 minus 0.5 divided by 2. Negative 4.5 plus 0.5 is negative 4.0. Divided by 2 is negative 2. And this one is negative 4.5 minus 0.5 is negative 5. Divided by 2 is negative 2.5. All right, so don't look so terrible that way, right? You can, as long as you divide everything by the same thing, you'll be good both sides. And it's always better when it equals 0 on that side, because 0 divided by anything is still that number. So I can factor it out and it doesn't matter. All right, just real quick, follow it up with a graph. That was our last one, if you remember. This one, and I'm going to show you the original one, right? 24x squared plus 108x plus 120. There it is, right? And if I zoom in, because that's what I want to do, I'm able to see my 2 points are at negative 2 and negative 2, 0 and negative 2.50, right? And just to show you for fun that this, let's see what it looks like. So it's going to be x squared, oops, don't know what I just did there, x squared plus 4.5x, 4.5x, and did I write plus? Nope, just making stuff up. Plus 4.5x plus 5. That's what that. Calculators will only do what you tell them to, and I have my caps lock on, so it messed it up. There it is, okay? So they're not the same graph, and that's what I wanted to do to show you, but they both have the same roots, right? We did take this off. We changed the problem, but we made it an equivalent problem. And both of our things, and actually the solution to these two things, where they cross is at negative 2 and at negative 2.5. So you can do it that way. You can simplify, and yes, that will always work so long as you divide it every single term by the same number. Okay, so there's another example. And here's your idea of quadratic formulas. You know, always make sure it's equal to 0. And simplify if you can. Factor things out. By dividing everything by 24, we factored out a 24, and we made our problem look a little bit easier rather than dealing with 11,000 something. All right, so hopefully that helps, and I will see you guys in another video.